Let's do exercise 3 from the problem set of probability models. In our house, there are 6 machines that work independently of each other with a stop rate of 10%. Calculate the following probabilities. We are going to start with part A. So we are asked to calculate the probability that exactly 2 machines are off. But first we are going to describe that x is our variable and it represents the number of machines that are off. Moreover, we know that x follows a binomial distribution with n equal to 6 and with a probability of stop rate of 0.1. Now let's continue with part A. So applying the properties of the binomial distribution, we are going to use this statement to calculate the probability of x that is equal to 2. Now take a look. We have just replaced the values. So if we do the calculus with the calculator, we know that this is equal to 0.0984. So this is the result of part A. In part B, we are asked to calculate the probability that at most 2 machines are off. That means that we are looking for the probability that x is smaller than 2. We cannot find this result in the tables, neither we can calculate it like in part A. So we are going to make simpler that expression. So we know that the probability that x is smaller than 2 is equal to the probability that x is equal to 0 plus the probability that x is equal to 1 plus the probability that x is equal to 2. In order to make the calculus simpler, we are going to look for the values in the tables. As we said previously, we are going to look for the values in the table. So here we have a binomial distribution table and we are going to find the probabilities we need. So remember that the number of experiments, it was 6. So we are going to look at this part of the table. Moreover, the probability was equal to 0.1, that is this column. And the number of success experiments were 0, 1, and 2. So we just have to follow and we'll find that these 3 are our probabilities we are looking for. Now we've replaced the values we have previously got from the table. And if we sum of all of them, we got that the probability that x is smaller than 2 is equal to 0.9841. So this is the result of part B. Remember that here we have used the tables to calculate the probabilities, but if you want, you can use the expression we used in part A to calculate the probabilities. However, this is a longer way, so sometimes it is easier to do by using the tables. Now let's continue with part C, where we are asked to calculate the probability that at least two machines are off. That means that we are asked to calculate the probability that x is greater than 2. So following the same procedure that in part B, we are going to make this expression in some part, that it is equal to the probability that x is equal to 2 plus probability x is equal to 3 plus probability x is equal to 4 plus the probability x is equal to 5 plus probability x is equal to 6. Now, as in the other part, we'll look for the results in the tables as it is simpler and easier. So here we have again the table, and the values we have to look for are here, right? So now we just have to replace and then sum of all of them. So now once we have all together, we just have to sum all of them, and this is equal to 0.1143. So this is the final result of part C. Now let's continue with part D. We have to calculate the probability that all the machines are running. So that means that there's no machines off. So we are looking for the probability that x is equal to 0. So this is easy because we have just to look for the value in tables, or otherwise we can do like applying the formula of binomial distribution. So here we use the formula of binomial distribution, and doing the calculus with the calculator here, we obtain that result for part D. Now we have another part where we have 8 machines, and the percentage that they are stopped is 60%, and we are asked to calculate the probability that exactly 3 machines are stopped. So being x the number of machines that are stopped, we know that previously it follows a binomial distribution with this condition, okay? So we know that this is a binomial distribution as it is the sum or the continuous repetition of several Bernoulli experiments, in this case 8 experiments. So here we have the result. We have done it with the formula of binomial distribution, as the probability is 0.6 and we cannot find it in the tables. But otherwise, if we would do it by using the tables, we have had to change the variable. I mean, instead of call x the number of machines that are off, we should have called it the number of machines that are in. So the probability that the machines are in is 0.4, and we can find it in the tables. Here you have the distribution it would be if in case we want to look for the value in the tables, but we are not going to do that, so just in case you are interested. This video was done by María José López Martínez in the academic year 2012-2013. Thank you for listening.